Well, in this video, we are supposed to also do another example involving differentiation. How do we apply differentiation to find the equation of normal and the equation of tangent? Now, in our previous video, we explained how we can talk about the equation of normal and the equation of tangent. Tangent means the equation and the line are parallel, and normal means the equation and the line are perpendicular to each other, and they are gradients. If you have those that are normal, they are gradients. If you multiply them, you get -1, and those that are parallel, they have equal gradients. So we are supposed to work out an example. Y is equals to x cubed plus 2x squared plus x minus 1, and we're supposed to find the equation of normal and the equation of tangent, given that this curve intercepts y at 3. So how do we go about it? So the first thing we should do is to find the gradient function. The gradient function of this curve is going to be its first derivative. The first derivative, y prime, is going to be equal to 18x squared plus 4x plus 1. Now, we're supposed to use this point given here to be able to find the gradient of this function. Now, we're going to insert x value. So we're going to find the gradient of this curve at a given point. Now that we have been told that the curve intercepts x at 3, then we know something, that at y-intercept, the value of x is 0. It means we are going to have 0 at this point. Therefore, y prime is going to be equal to 18 multiplied by 0 squared 4 0 plus 1, and y prime equals to 1. That means the gradient of this function at this point is exactly 1. So the first thing we are supposed to do is to find the normal, the equation of the normal. So to find the equation of the normal, the first thing we should have is a point. And of course the point, we have known the point because we have the value of x at that point, which is 0, 3. The value of y at that point is 3, and then xy, and of course we need to find the gradient of our equation at that point. So when we talk about the normal, we talk about the perpendicular. That means if you multiply m1 multiplied by m2, we should get -1. -1 multiplied by m2 equals to -1. That means m2 is equals to -1 as well. Now we have a point, another point, and the gradient. We can find the equation. To find the equation, then we have y minus 3 divided by x minus 0 equals -1. Y minus 3 divided by x, is equals to -x plus 0. That is y is equals to -x plus 3. And that becomes the equation of normal to our curve. Now, for us to work the equation of tangent, then you need to take the point, the same point 0, 3, and xy, and remember, since they are tangent, then it means their gradients have to be the same. So the gradient is equals to 1. So that means y minus 3 divided by x minus 0 equals to 1. Y minus 3 is equals to x minus 0, and y is equals to x plus 3. And that becomes the equation of normal, and that becomes the equation of tangent to our curve here. Of course, it's good to remember that the equation of normal, the gradients are, the product of the gradients is -1, and for those that are tangent to each other, it means their gradients are equal, and that's how it's done.